Part 1. At precisely 700 hours Universal Time, on a morning that seemed otherwise ordinary, the world's most sophisticated defense systems stirred in unison. Satellites shifted their gaze toward the black canvas of space. High-altitude observatories recalibrated their lenses, and hidden command centers, deep within mountain ranges and frozen tundra, began to hum with synchronized precision. It was as if the planet itself had taken a breath, sharp, collective, and uneasy. What could cause such a reaction? A missile launch? A solar flare? No, nothing so immediate, nothing so terrestrial. According to the official statements, this was merely a response to a comet, an object catalogued under the name 3 Atlas. Harmless, they said. Routine, they insisted. But those who have spent their lives decoding the subtleties of official language, those who understand how silence can carry as much weight as words, began to sense a contradiction. NASA's Planetary Defense Division, normally meticulous and reserved, was suddenly everywhere. On news networks, social platforms, and press briefings, repeating the same 4 words with calculated calm. No threat to Earth. Yet while their voices soothed, their actions betrayed a different story. Ground-based radar arrays reserved for deep space monitoring had gone active. Infrared sensors meant to detect missile signatures were reoriented toward the heavens. Systems that normally slept in standby were running continuous diagnostics. The world's defensive apparatus, military, civilian, and scientific, was quietly, unmistakably preparing for something. The name itself, 3 Atlas, sounds innocuous, almost poetic. It was discovered, fittingly, by the Asteroid Terrestrial Impact Last Alert System, a network designed to warn humanity of potential cosmic collisions. The first images arrived from Chile, a faint shimmer crossing the dark expanse of July skies. Its movement was swift but strange. When astronomers ran their orbital models, the data refused to conform. This was no familiar looping comet, no returning traveler bound to the sun by gravity's invisible leash. Its path was open, hyperbolic, the signature of something that had never been here before and that, once it passed, would never return. At first, the excitement was purely scientific. Interstellar objects are rare. Only 2 had ever been confirmed before. Yet even in those first days, whispers began. The numbers did not add up. Its brightness shifted irregularly, pulsing in uneven rhythms, and its composition, as measured by spectroscopy, appeared to defy known categories. The spectrum didn't resemble a frozen body of water and dust. It resembled something metallic, layered, almost engineered. Still, the agencies urged calm. A scientific opportunity, they said. But the International Asteroid Warning Network, an organization that coordinates planetary defense efforts worldwide, quietly elevated its operational status to high alert. That's not a phrase used lightly. It's reserved for events that could, in theory, escalate to planetary defense measures, impacts, large-scale debris, or unexpected acceleration patterns. And so, as telescopes across 6 continents locked their lenses on a single glowing point in the void, the question grew louder in the minds of those watching. If 3 Atlas is harmless, why is Earth preparing as if for war? Perhaps some reasoned it's merely caution, a legacy of earlier false alarms, a test of planetary defense readiness. But others weren't so sure. In the data streams trickling from observatories, something anomalous was emerging. The object's orbit didn't curve naturally under the sun's influence. It cut space with a precision that suggested deliberate geometry. And its chemical emissions, light decoded into elemental fingerprints, displayed ratios unseen in known comets. It was venting carbon dioxide in quantities 8 times higher than water vapor. No comet behaves like that. None that we've ever seen. And as it drew nearer to the inner solar system, that imbalance didn't fade. It intensified. Then came the first quiet adjustments. The James Webb Space Telescope, whose observation schedule is planned months in advance, suddenly shifted focus. For 48 hours, it tracked 3A Atlas in the infrared. Officially, this was part of an ongoing survey. Unofficially, it was an emergency redirect. And when data began to flow from Webb's instruments, some of it, unusually, was withheld from public archives. In the halls of the International Astronomical Union, in research centers from Pasadena to Darmstadt, and in classified briefings far from public view, questions multiplied faster than answers. Could it be that 3A Atlas wasn't a natural object at all? Could its peculiar chemistry, its sharp trajectory, its rhythmic glow point to something designed? Something that might even be watching us? For now, the official story remains intact. It's just a comet. Just another wanderer. Yet the mobilization we're witnessing says otherwise. The scale of coordination, the subtle urgency, the machinery of secrecy, all of it speaks to a deeper unease. In this episode, we'll peel back the layers of this unfolding mystery. We'll explore why NASA's most advanced defense networks have awakened in unison. We'll look at what the International Asteroid Warning Network isn't saying, and what might lie hidden in those encrypted data channels humming quietly beneath the surface of reassurance. Because if 3I Atlas truly poses no threat, why does Earth seem so afraid? And perhaps more importantly, what if it isn't afraid at all? What if it's preparing? Next, Part 2, 3A Atlas, designated officially as C2025U1, entered our catalogs quietly on the 1st of July, 2025. Within days, the whisper of data traveling through the deep space networks ignited a quiet storm. Astronomers knew they were looking at something unfamiliar, but as the numbers solidified, it became clear that this was not simply another icy wanderer from the outer solar system. Its orbit was open, hyperbolic, meaning it was not bound to our sun by gravity. It came from elsewhere, from the dark interstellar gulf, and would, in a matter of months, leave forever. NASA's official line was calm, measured, even rehearsed. No threat to Earth. That phrase became a refrain, echoed across press releases and interviews. Yet while the words projected composure, the reality unfolding behind the scenes was far from tranquil. Every major observatory capable of deep space tracking was instructed to begin continuous monitoring. Data links to the International Asteroid Warning Network, IAWN, flared to life. Military-grade radars, the kind designed to detect intercontinental missiles, began scanning upward. These systems were not designed for routine astronomy. They were instruments of precision, of defense, of readiness. And they were all suddenly focused on a single object more than 270 million kilometers away. The event was officially termed the 3 Atlas Comet Astrometry Campaign, a global initiative scheduled to run from late November 2025 through late January 2026. On paper, it was a scientific collaboration meant to refine orbital models. In practice, it was planetary coordination on a scale that mirrored emergency procedure. Participation requests were sent to universities, national observatories, and even amateur astronomers. Every hemisphere, every longitude was asked to contribute, ensuring that the comet would never slip beyond collective sight. This level of coverage was unprecedented for an object so distant, especially one that by all public accounts posed no threat whatsoever. But the reasons for this intensity became more apparent as the first readings arrived from spectroscopy teams around the globe. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, and the James Webb Space Telescope all captured data that defied conventional classification. The spectral lines did not match ordinary cometary chemistry. Instead of the familiar fingerprints of water, ice, and dust, they found a dominance of carbon dioxide nearly 8 times that of water, an imbalance unseen in any known cometary class. Some astronomers speculated that 3 Atlas might have formed in the frozen outskirts of another solar system, perhaps around a star richer in carbon. But others noted something more troubling. The data seemed to suggest a process, not a remnant. The emissions were regular, pulsing with mechanical consistency rather than chaotic bursts. Even more unsettling were the polarization readings. Polarimetry, the study of how light scatters off dust particles, can reveal much about the shape and composition of the material surrounding a comet. The instruments returned results indicating extreme negative polarization, a technical term meaning the light behaved in ways that could not easily be explained by natural dust or ice. Some models attempted to reconcile the readings by proposing exotic carbon structures or metallic compounds. But each theory required conditions so unlikely that even their proponents admitted the explanations felt forced. Then came the nickel. On the 15th of October, the Keck Cosmic Web Imager detected narrow emission lines corresponding to neutral nickel atoms, isolated, unbound, shining faintly against the comet's glowing coma. At first glance, nickel might not seem unusual. Many comets contain traces of metals. But here, there was something missing. Iron. In nature, nickel and iron are inseparable companions, forged together in the hearts of dying stars. To find one without the other is akin to seeing lightning without thunder. It points to a process of fractionation, a separation of elements under specific and often artificial conditions. The presence of nickel without iron suggested either an unknown natural phenomenon or something far stranger. The manipulation of matter. On Earth, the same kind of separation can occur only through industrial processes involving compounds like nickel tetracarbonyl, a volatile gas formed when nickel reacts with carbon monoxide under controlled pressures and temperatures. In laboratories and refineries, this gas is used to purify metals. But the idea of such a reaction occurring spontaneously inside a comet drifting through the void stretches the limits of chemistry, as we understand it. NASA's public communications did not mention nickel at all. The discovery was instead circulated through academic preprints and internal memos, many of which were marked restricted dissemination. Within weeks, radar stations under the command of the United States Space Force and allied agencies began tracking 3I Atlas with an intensity normally reserved for inbound asteroids. Infrared platforms like NEOWISE were repurposed, their observation schedules cleared to focus on the object's thermal emissions. The Deep Space Network, those vast radio antennas that maintain contact with distant spacecraft, reallocated time slots to gather echoes from the comet's surface. These are not casual actions. They require high-level authorization, and they do not happen without reason. At the same time, across the Atlantic, the European Space Agency mirrored the move. Its Mars Express orbiter, originally scheduled to map geological formations on the Martian surface, quietly shifted its imaging instruments to capture 3I Atlas as it crossed near the orbit of Mars. The adjustment went unannounced, only appearing later in mission logs. Even private observatories, such as those operated by the Vera Rubin Observatory project, reported sudden interest from unnamed institutions requesting real-time telemetry access. Something was clearly driving the coordination, something more urgent than science alone. In late October, a leak appeared in a major newspaper. The article cited unnamed sources within NASA's Planetary Defense Coordination Office, claiming that certain high-risk protocols had been activated in monitoring mode. Among them, the alleged existence of an internal procedure known as IPD-9, which reportedly governs the response to unidentified deep space anomalies. The story was quickly denied, yet observers noticed that subsequent press briefings became markedly more cautious. Questions about defense coordination were met with silence. Requests for comment were redirected to communications staff, who offered only one phrase: no threat to Earth. But in the data itself, something extraordinary was happening. 3A Atlas was brightening, not gradually, as comets usually do when they near the Sun, but in rhythmic surges. Its light curve rose and fell with near-perfect intervals, as if responding to some unseen timer. When analyzed in the frequency domain, those pulses produced harmonics, patterns that some described as structured. To be clear, no scientist publicly claimed that these patterns represented communication, but in private, many admitted they had never seen anything like it. Around this time, the International Asteroid Warning Network began using a phrase not found in any of its public documents: anomaly detection readiness. The concept was simple but revolutionary, to prepare not only for kinetic threats such as collisions, but also for behavioral anomalies, patterns of motion or emission that might suggest non-natural origin. The very inclusion of that term marked a shift in planetary defense philosophy. No longer was the goal merely to guard against impacts. Now, the mandate included identifying intent. For decades, astronomers have dreamed of interstellar visitors, but they always imagined comets or asteroids, not machines. Yet, as data from 3i Atlas accumulated, the line between natural and artificial grew ever thinner. Its trajectory through the ecliptic, the plane on which most planets orbit, was too aligned to be coincidence. For an object arriving from random interstellar space, crossing that plane within 5 degrees of perfect alignment was statistically improbable. It was like throwing a dart from another continent and striking the equator dead center. Coincidence, perhaps, but enough to raise eyebrows among those who live by probabilities. Then there was its speed, 61 kilometers per second relative to the Sun, more than 3 times faster than Voyager 1, humanity's most distant probe. That velocity meant it was not captured by solar gravity. It would come and go without pause. Yet despite such velocity, its motion through the solar system was remarkably stable, unaffected by gravitational tugs or solar wind perturbations to the degree one would expect. The precision of its path implied either an extraordinary internal mass distribution or active stabilization, the kind achieved only by maintaining balance, as if guided. By early November, rumors circulated of classified signal monitoring. The SETI Institute, though publicly silent, was believed to have redirected the Allen telescope array toward the coordinates of 3i Atlas. If they detected anything, it has not been disclosed, but a few independent radio astronomers reported faint, narrow-band emissions near the hydrogen line, one of the universal frequencies used in astrophysical communication studies. The signals were fleeting, intermittent, and impossible to confirm. Still, they added fuel to the growing fire of speculation. Meanwhile, the global astrometry campaign intensified. Observatories across Asia, Europe, Africa, and the Americas worked in shifts, ensuring continuous coverage. The data was streamed to centralized servers, where algorithms cross-checked for deviations. Each minute of observation was logged, each reading catalogued, each anomaly flagged. The pattern of coordination mirrored military readiness, redundancy, confirmation, and rapid response. Dr. Linley Johnson, NASA's long-serving planetary defense officer, made a rare public statement in which he reaffirmed that 3 Atlas would pass no closer than 1.8 astronomical units from Earth. Yet within that reassurance was a subtle admission. "We continue," he said, "to study the object for its unique photometric and compositional properties. Our understanding is evolving." Those last 3 words, "our understanding is evolving," became the unspoken motto of the campaign. The deeper scientists looked, the stranger the object appeared. Radar echoes suggested a nucleus not spherical but elongated, possibly segmented, reflecting in a way that implied sharp edges or planar surfaces. Models of its rotation indicated a tumbling pattern inconsistent with the outgassing expected from a natural body. At times, it seemed to adjust its spin, as though compensating for torque, behavior that, in any spacecraft, would be interpreted as control. Yet even as these findings accumulated, the public narrative remained steadfast. A harmless comet. The contrast between words and actions grew so wide that even veteran astronomers began expressing frustration. Dr. Maya Khanna of the European Southern Observatory described the situation as the most intensely studied non-threat in history. Her comment, though mild, echoed through scientific circles. Why mobilize planetary defense infrastructure for something that poses no risk? Why deploy infrared surveillance satellites, radar arrays, and classified instruments if the object's path is perfectly safe? Some pointed to precedent. The near-Earth asteroid Apophis, back in 2004, had triggered similar global attention when early calculations suggested a potential impact. But that concern was resolved within months and tracking scaled down. 3A Atlas, on the other hand, only grew in attention as the data confirmed no danger. It was as though certainty itself was the reason for heightened scrutiny. By mid-November, the IAWN convened an extraordinary coordination meeting. Attendance was by invitation only, and the agenda was not publicly released. But leaks from attendees hinted at discussions involving non-gravitational acceleration, spectral anomalies, and instrument synchronization with classified assets. These phrases, once the realm of science fiction, were now embedded in the lexicon of planetary defense. And then came the revelation that turned quiet speculation into open debate. The James Webb Space Telescope's infrared spectra, after weeks of processing, revealed not only carbon dioxide and water, but trace amounts of carbon monoxide and cyanide compounds arranged in ratios that suggested organized layering within the coma. The data hinted at stratified ejection, material venting from specific zones, timed and measured. In nature, such precision is rare. In engineering, it is expected. The implications were staggering. If this object was not natural, then humanity was witnessing, for the first time in its history, the passage of an artifact from another civilization. Yet if that possibility was even whispered in official corridors, it was quickly buried under protocol and prudence. The world, it seemed, was not ready to hear those words spoken aloud. Still, the scientists kept watching. Every night, under skies both clear and storm-choked, telescopes turned their mirrors toward that strange traveler. Some did so out of duty, others out of curiosity, and a few because they sensed that history itself was unfolding, that future generations might look back at this moment and say that in the autumn of 2025, humanity stared into the void and saw, for the first time, something staring back. Whether 3A Atlas is a natural interstellar fragment or something infinitely more complex, one truth has become inescapable. Earth has changed. Not because of impact or destruction, but because of awareness. The systems of defense, the protocols of secrecy, the scientific vigilance, all have converged in a way that suggests our species is beginning to understand that the universe is not silent. What happens next will determine whether this realization becomes a triumph of discovery or a quiet prelude to something far greater. The campaign continues, the data grows, and through it all, 3A Atlas races outward, away from the sun, trailing not dust or vapor but questions, luminous, unsettling, and unending. Part 3. Every object that crosses the void carries a story. Some stories are written in the scars of radiation and ice, others in the chemical fingerprints of alien suns. 3I Atlas, whatever it truly is, has already rewritten the boundaries of what we thought possible. And behind its spectral glow lies not just the mystery of its origin, but a reflection of our own evolving place in the cosmos. For centuries, humanity has stared upward in wonder, searching for meaning in the stars. We've mapped the heavens, charted the dance of planets, sent probes across interplanetary space, but always with the assumption that we were the observers, not the observed. With 3I Atlas, that assumption feels less certain. its discovery may forever mark a turning point in how we perceive the sky. Astronomers have long catalogued comets as relics of creation, frozen archives of the early solar system, untouched by time. But this object is not from here. Its hyperbolic trajectory confirms it as interstellar, an emissary from beyond our neighborhood, traveling through space for perhaps millions, even billions of years before intersecting our tiny orbit. Its arrival is an accident of gravity, a coincidence of motion, and yet its path, perfectly aligned with the ecliptic plane, feels almost purposeful, as if drawn by an unseen hand. The scientists at the heart of this unfolding story are no strangers to awe. Dr. Linley Johnson, whose calm reassurances have become the public voice of NASA's planetary defense program, began his career studying the trajectories of near-Earth asteroids. His work once focused on preventing catastrophe. Now it may be redefining contact. He has spoken little beyond official statements, but those who know him describe late nights at the Jet Propulsion Laboratory, screens awash with numbers, the faint tremor of wonder in his voice as he whispers that the data doesn't fit. There's a quiet irony in that the man trained to defend Earth from celestial threats now faces something that cannot be categorized as threat or safety, danger, or discovery. Then there's Dr. Amina Delgado, an astrochemist working at the European Southern Observatory. Her team was among the first to notice the imbalance in 3I Atlas's chemical emissions. The strange dominance of carbon dioxide, the flicker of metallic lines. For weeks, she has refused interviews, focusing instead on her analysis of the spectral data. In a rare statement during a closed symposium, she said, "If this is a comet, then it is the most alien one ever found. And if it is not a comet, then we may be standing at the threshold of something extraordinary." Her words, measured and cautious, carried the weight of scientific restraint, yet beneath them one could sense the tremor of possibility, the sense that perhaps after all these centuries the universe had finally spoken back. Behind these figures are the machines, the instruments that have become our eyes beyond the sky. The James Webb Space Telescope, launched in late 2021, was designed to peer deep into the origins of galaxies. Yet its mirror, stretching like a golden petal into the darkness, has now captured something far more immediate, the reflection of our own curiosity. Its spectrographs, designed to read the light of the earliest stars, are now decoding the breath of an interstellar visitor. Each photon it collects from 3I Atlas tells a fragment of the story, a pattern of heat, a whisper of motion, a flicker of composition, all woven into data streams that stretch across the Earth like a new form of mythology written in numbers. And then there is the Atlas survey system itself, the sentinel that first noticed this faint anomaly moving against the fixed stars. 4 telescopes scattered across Hawaii, South Africa, and Chile, scanning the heavens every night for objects that might threaten Earth. Their name, the Asteroid Terrestrial Impact Last Alert System, was chosen to evoke vigilance, protection. But perhaps on that night in early July they became something more, heralds of a new chapter in human awareness. For it was their digital eyes that caught the first glimpse of 3I Atlas, an object whose nature might transcend anything those instruments were built to find. It is difficult to grasp the scale of what's happening, not just scientifically, but philosophically. For the first time, our planet's defense infrastructure has been activated not to shield us from destruction, but to seek understanding. The telescopes, satellites, and radars now watching this object form a new kind of network, one that unites science and security, curiosity and caution. It is as though Earth itself has opened its collective eyes, gazing outward with newfound intent. We are no longer waiting for impact. We are preparing for revelation. Among the scientists quietly contributing to the 3I Atlas campaign is Dr. Javier Mendez, an expert in astrometry based in Madrid. He has spent decades refining techniques to measure the precise motion of celestial bodies. In a recent lecture, he reflected on what makes this particular campaign unique. When you point a telescope at a comet, you expect it to behave like a comet. When it doesn't, you're forced to ask not just what it is, but who we are, that we might not recognize it. Those words have echoed far beyond the academic world. They capture the essence of this moment, that our understanding of the cosmos is expanding faster than our language can keep up. As 3A Atlas drifts farther from the Sun, its light grows dimmer, its features harder to resolve. Soon, it will vanish beyond the reach of our instruments, its secrets preserved in the cold silence between stars. Yet its impact on humanity will not fade. It has already left an imprint on our collective consciousness, challenging the borders between science and philosophy, between what we can measure and what we can only feel. For the engineers who built the telescopes and instruments now watching it, this has become something deeply personal. Many of them began their careers in an era when planetary defense was theoretical, when the idea of interstellar visitors was confined to textbooks. Now they are witnessing those ideas collide. The reality that our species has the power to detect, analyze, and even anticipate what drifts through the infinite dark. In their precision, in their data, lies something profoundly human: the refusal to turn away from mystery. The quiet heroism of this story is not found in grand gestures, but in patience, in the scientists who spend sleepless nights refining orbital models, in technicians calibrating sensors buried beneath the Antarctic ice, in programmers correcting the faint distortions of light caused by the turbulence of our own atmosphere. Each one, in their own way, contributes a brushstroke to the portrait of 3A Atlas, that cold enigma slipping silently through the sky. And yet, for all our progress, the questions remain vast. What if 3A Atlas is not a threat, but a messenger? What if it is not observing us, but reminding us that in the grand design of the cosmos, we are not alone in our curiosity? The notion is both exhilarating and humbling. If this object is a natural fragment of another world, then it carries within it the memory of an alien sun, the chemical echo of a different dawn. If it is something more, if it bears traces of intention, then it may stand as the first tangible sign that intelligence is not bound to Earth. As the international campaign nears its conclusion, the data collected will take months, perhaps years, to interpret fully. Papers will be written, conferences convened, theories proposed and discarded. Some will argue that 3A Atlas is simply an unusual comet. Others will suggest it is a fragment of a shattered planet, a relic from a distant system. And a few, quietly, will hold to the possibility that it is something neither natural nor mechanical, but something that transcends those definitions entirely. Perhaps that is the true legacy of this event, not the discovery of what 3A Atlas is, but the awakening it provokes within us. It forces us to confront the limits of our comprehension, to look beyond the comfort of established models, to accept that the universe may still hold wonders that defy our categories. In the decades to come, long after this interstellar visitor has disappeared into the black, its influence will persist. Children who watch the news in wonder will become the next generation of scientists, engineers, and dreamers. They will build new instruments, design faster probes, and send them beyond the heliosphere into the same interstellar currents from which 3A Atlas emerged. Perhaps one day, one of those missions will find another such traveler, or follow its path to the star from which it came. And when that day arrives, we will remember this moment, October 24th, 2025, as the day when humanity first understood that watching the sky is not just an act of defense or curiosity, but of connection. That every flicker of light, every whisper of data,